So section 8.5 is equations in the Cartesian coordinate system. And we are going to start by taking a look and remembering what the Cartesian coordinate system looks like. You have this already in your notes, there's nothing more really to add, but some reminders of things. We always write the x coordinate and then the y coordinate, right? So it always goes x, comma, y for an ordered pair. So we always look at how far left and right we go along the x-axis before we look at how far up and down we go along the y-axis. Our quadrants are numbered starting with the top right corner, and they actually go counterclockwise around. The top right corner and then counterclockwise feels a little bit counterintuitive to how we read clocks. The reason that they were numbered the way that they were is because the convention was done by someone who's left-handed. So I think that's kind of an interesting fact. The origin is the point at the center of the graph, 0, 0. We have positive x on the right-hand side, negative x on the left-hand side. Right, these are positives and these are negatives. And positive y is at the top of the graph and negative y is at the bottom of the graph. All right, so we're going to take a look now at some specific details using this coordinate grid. So I mentioned a point is a location in the Cartesian coordinate system given by an ordered pair of numbers, A, B. The abscissa, or the x-coordinate, is the first coordinate, x left and right. The ordinate, or the y-coordinate, is the second coordinate. And the resulting picture that we get when we plot points or connect them, whatever the situation is called a graph. So what you see right here is the axis. There is no graph yet on it. The graph is all of the points that would be placed on there from an equation or a set of data, okay? There's no graph here. This is just an axis. A vertical line will have an equation x equals some specific value. For example, all points that are on the blue line on my screen have the same coordinate for x. X is 2. Now their y values are different. So if I talk about this point is 2, 2, whereas this point is 2, 1. The y coordinates are different, but the x coordinates all match. And because the x coordinates all match, we actually get an equation that's x equals that same number that matches 2. Now, if we're talking about horizontal lines are much like vertical lines. They have a y-coordinate, however, that matches everywhere. So again, if I talk about this y-coordinate here, or this ordered pair here, I have the point 1, 3, right? But if I talk about the point right here, I have the point 3, 3. The y values match, even though the x values vary. And that's the reason we get an equation that says y equals, in this case, 3, because all of the y values equal 3. I really like pictures of these if I'm trying to decide do I have a horizontal line, a vertical line, and so forth. But there is one more way that I always like to show for maybe remembering which ones are vertical lines and which ones are horizontal lines. And it comes by way of an acronym, HOIVUX. So I saw, it was when I was in graduate school and I was teaching. Do you know that when you go to a state school, you're likely not to get a professor, you're likely to get another student as a professor? That's what I was to start with, and so I was 20 years old and teaching 18 and 20-year-olds because we were all about the same age. And I saw a fellow student teaching and talking about HOIVUX, and I thought it was really good because some of us remember things when we have acronyms, and so it's nice. HOIVUX stands for the following. We have horizontal, that's H, so let's just write them in first. So H is for horizontal. The O is actually the number 0, and it's talking about the 0 slope. So it's standing for 0 slope. Change the thickness of that just a little bit. The Y stands for the equation Y equals a number. So I'm just going to put the pound sign for number. Okay, so Y, I know that you think that that's a hashtag. Did you realize it's not, right? Okay, it's a pound sign. Yeah, Y equals a number. All right, so the V stands for vertical. The U stands for the word undefined. And it's undefined slope. I'm kind of out of space, but we'll put it in there. And then the X stands for X equals, like the equation X equals a number. So it works something like this. This tells me that horizontal lines have 0 slope, 0, they're flat, and they have equations Y equals a number. Vertical lines have undefined slope. We haven't really talked much about slope, we will in a minute, but undefined slope because they're straight up and down. And their equations are X equals a number. So if you like it, use it, write on your note card, whatever. If you don't like it, that's fine. I am a fan of the graphs themselves helping me out, but I think not vertically. I think visually, that's the word I wanted, visually, so that helps me out. So some ideas about equations of lines. In general, lines that are not vertical have equations that can be written in the form Y equal mx plus b. It's probably one of our so dearly loved formulas. We like them for lots of reasons. One, because we can see the m and the b, knowing how to graph them pretty easily. We like them because calculators like them. Or easy to put it in a calculator if it's written in that form. This is called slope-intercept form. M stands for the slope. Slope is direction and steepness. So how tall or steep is the graph? Is it going up, left to right? Does it go up, down, or does it go from down to up? B stands for the y-intercept of the line. That is where it crosses the y-axis. Now, B is not the y-intercept. It stands for the y-intercept. The y-intercept is always a point, and it is the point 0b. So this is actually my y-intercept. The B in the equation simply helps me to identify the y value for the y-intercept. Okay? So please don't tell me the y-intercept is 5. It's not 5, it's 0, 5. Now, in general, a linear equation can be written as y equal mx plus b, but only when it's not vertical. So if we sort of broaden our description to say all lines, they can either be written as y equal mx plus b or as x equals whatever the number is, because it's a vertical line description. So you can always write them in one or the other. Now, you might be thinking to yourself, well, what about those horizontal lines you just did a moment ago? You're not listing them. Well, let's say we had a horizontal line, which is like y equal 5. It actually can be written in that first form. It's just 0x plus 5. You might look at that and say, well, that's dumb. Why would I write 0x plus 5? Well, that's not the point. The point is simply that it can be done, not that we would generally write it in that fashion. Okay? So you always are able to write it in this one or this one. Now, a little bit more about the y-intercept. The y-intercept is a point with coordinates 0b that tells us how many units above if b is greater than 0 or below if b is less than 0 that we are from our origin. Okay, our graph crosses at that location. That's actually not special about lines. We're working with lines, but any graph that crosses at the the y-axis at a specific point, it's called the y-intercept. And the x-intercept is similar. It's just where it crosses the x-axis. Again, nothing special or specific to lines. That just happens to be the type of graph we're working with. If it crosses the x-axis, you'll notice that the y value is 0. If it crosses the y-axis, the x value is 0. Okay, so x will have an x value, y will have a y value, and the other coordinate will be 0 when they're crossing. We mentioned intercepts. the other one I've mentioned so far and haven't talked in depth about is slope. So slopes are rates of change of y values as corresponding x values change. It's a relationship. So a positive slope, we always read a graph the way we would read English, from left to right, okay? So when I'm reading a graph from left to right, if a graph has positive slope, we think about it from left to right going uphill. And it would look something like that. Of course, lines on the end, or arrows on the end. And if you have a negative slope, again reading from left to right, you would be going downhill. And your graph would look like this. Maybe steeper, maybe not as steep, but it would be looking from left to right like you're going downhill. Zero slope looks flat. Zero slope is like when you're, I don't know if any of you ever run on treadmills, but it's the zero on the treadmill. Zero incline is zero slope. Okay, there is no incline, it's flat. If you actually have no slope, that's not the same as zero. So zero does not equal no. No slope means the same thing as undefined slope, which I would far prefer, yeah, that was right, to the word no. The word no feels ambiguous to me. It feels like it could mean either one. It means an undefined. Undefined means that you have a vertical line. So your slope looks like, or your graph looks like this. All right, a little bit more about slopes. Slopes farther from zero are farther from horizontal or steeper. So if you have a slope that's like 50 compared to a slope that's 5, it means it's steeper. It's bigger number farther away from zero. But the same is true if it were negative 50. It just would mean it's steeper, but it's going downhill instead of steeper and going uphill. Parallel lines have the same slope. So if one of the slopes of a line is 5 and you've got a line that's parallel to it, it will also have a slope of 5. And that seems like it should make sense. Parallel lines should be the same amount of steepness as one another. There's one exception to that, and that's if you have vertical lines. If a vertical line has undefined slope, then another vertical line will also have undefined slope. But then we can't really say that their slopes are equal because their slopes have no meaning anyway. So they still have the same kind of idea. We've described them as this word undefined, but that's actually not a number. So we can't sort of compare them the way we would compare numbers. But they would be both undefined slopes. So let's actually talk about slope. What is slope concretely instead of this sort of vague way of describing steepness? Slope is actually the change in y values divided by the change in x values. You can also think of it as the vertical change divided by the horizontal change. Or you can think of it as rise over run. Those are all verbal descriptions of slope. If I actually give you two specific points, x1, y1, and x2, y2, we can write the slope sort of in an equation type form. It's actually a formula or an expression. And it's y2 minus y1 over x2 minus x1. A couple of things. You may have seen it written this way before, y1 minus y2 over x1 minus x2. That's totally fine. There's nothing wrong with that particular formula or expression for it, as long as the ones both are in the same spot, you know, on top of each other, so to speak, and the same for the twos. Then we're in good shape. They just have to pair up appropriately. If you pair them up backwards, you're going to get the wrong value. You'll get the wrong sign is what you'll get. You'll get a positive sign instead of a negative or vice versa. Now you might notice one more condition right here. It says as long as x1 does not equal x2. So think with me in terms of an equation point of view, expression point of view. What would happen if x1 and x2 are the same value? You would try to divide by 0, right? And division by 0 is an undefined operation. And that's why we call this slope undefined. Because if the x value is equal to the same thing, I would be having a vertical line. And then the slope, or the attempt to find the slope, would come up with an undefined value. So that's the coordination between those two kind of expressions. All right, so let's talk about perpendicular lines specifically. We mentioned parallel. Parallel lines have the same slope. Perpendicular lines, two non-vertical lines, whose slopes are m1 and m2, multiply to give you -1. And that's fine. You're probably more used to it being written this second way that's on here, which is, in other words, the slopes of perpendicular lines are negative reciprocals of each other. So let's do a couple of examples of that. Let's say that my first slope, I'll call it m1, is 5/4. What would m2 be if I did the negative reciprocal? Right. If first one's positive, second one's negative, and then I would flip the fraction to be 4/5. Those are negative reciprocals. Now, if you think about what it's saying at the beginning, it's saying that if I multiply 5/4 by -4/5, I will get -1. Do I? Yeah, I do. So that's actually the description your book is using, is the first one. And when you multiply the two reciprocals together, the negative reciprocals together, you get -1. So let's try just a couple more. What would happen if I had a slope, m1, that was 1/3? What would I get for my negative reciprocal slope, my perpendicular slope?
-3.
Yeah, -3. You could write 3/1 if you wanted to, but 3/1 is just 3. And you can check to make sure that visually speaking that makes sense. 1/3 times -3. Will that equal -1? Yeah, it will. So what happens if you have a slope that's -2? What would my second slope have to be for them to be perpendicular? Yeah, 1/2. And it would be positive, right? The signs on them have to be opposite of one another, so it would be 1/2. Excellent. So now we're going to do some examples where we have more than just the slope to consider. We're going to find an equation through a particular point perpendicular to a particular line. And I'll show you a couple of ways to do this, one of them using the information that I've given you so far, and one of them I'll show you an additional equation of a line. If you'd like to use it instead, you may use it. So the first thing to recognize is that we have an equation already given to us that has a slope. What is the slope for this equation? 2. We want a line that's perpendicular. So what will our slope be? Good, it's -1/2. Everybody good so far? In order to deal with this situation, we need a point and we need a slope. The point was given to us, the slope we had to conclude from the other pieces of information. So now we have a slope. Now the equation that I've given you so far, the only one for finding a line, is y = mx + b. You were not given b. You're given a point, an ordered pair. We figured out what m was, so we were good to go on that. M is -1/2. But this ordered pair that we were given, whoops, I didn't mean to do that, I meant to do this, actually is an ordered pair x, y. Which means one way to do this problem is to plug in the x and the y into this equation and figure out what b is. So y is 2, x is -4, and I can use those pieces of information to solve for b. So what's the benefit of this? Well, the benefit of doing it this way is I only need to know one equation for a line, and that is a benefit. The drawback is that once I find out what b equals, a lot of times students will stop. And they'll think they're finished when they didn't actually give me what the question asked for, which was the equation of the line. So there's pros, there's cons. I've got a 2 on the left. What is negative 1/2 times negative 4? That's a positive 2 plus my b. What's b? It's 0. The b value here must be 0. So what does that mean? Well, it means this equation up here that I had everything in it but b can now be rewritten with the b, wait, what was it? Negative 1/2. Can now be rewritten with the b plugged in. It's plus 0. So if you want to write the plus 0, that's fine. But of course, plus 0 doesn't change the value, so we could also leave it off. It looks kind of funky, but it's actually a negative there. Okay, happier with that. So our equation of our line is y equal negative 1/2 x. Allie.
I'm sorry, I'm late. Where did you get the 1/2 again, the negative 1/2?
So we came up with the negative 1/2 because we used the other line that was given to us. The other line that was given to us had a slope of 2, and perpendicular lines have negative reciprocal slopes. So the negative reciprocal of 2 was the negative 1/2. Okay? So this is one way to do the problem. Let me show you another option using one equation that I haven't given to you yet. There's another equation for a line called the point slope form. Point slope form looks like this. It is y minus y1 equals m times x minus x1. That's what it looks like. I'd like to show you where it comes from because it kind of looks like it appears out of nowhere. It actually comes from the equation, the equation for slope over here. The equation over here for slope says that m equals y2 minus y1 over x2 minus x1. And if I were multiplying the x2 minus x1 to both sides, like cross multiply, right? This is like m over 1. I would end up with m times x2 minus x1 equals y2 minus y1. And with the exception of the fact that these say y2 and x2 instead of just y and x, that's the exact formula I just wrote down on the other side. I mean, it's flipped from the left side to the right side. I turned it around. But it's the same formula as this right here. Everybody see that okay? So it's not really appearing out of nowhere. It's just a rewritten part of what we've already used. Now, sort of the negative of this formula is that it's not usually presented in such a way that students recognize that it's the same formula they already saw. And so it's now a third formula they have to memorize. And some of your students are not going to be very good at memorizing things. It's just some of you probably aren't very good at memorizing things. Just the nature of the way that our different minds work. So for some students, having an additional formula to memorize is a negative. However, this has a very nice positive in the fact that I have a location to put in all three of the values I have. I have a y1, I have an m, and I have an x1. So once I plug those three individual numbers in and I simplify things, I don't have to remember at the very end, like I did over here, to go back to an equation I had and replace something in it. I'm just done. So there's some benefits to it. So if we take a look then at what we have here, y is simply the general y value for any point on our graph. y1 is the specific y1 that was given to us, which was, in the problem, what was it? Somebody said it, 2. The m we found together was negative 1/2, and the x given to us in the problem was what? Negative 4, yeah. So I have x minus negative 4. Technically speaking, this is an equation of a line. It's not in a very friendly form. It looks kind of messy, and it can be cleaned up, so we will. We're going to clean it up and get it into the same y equal mx plus b form that we have on the other side of my screen, in part simply to compare that they're the same thing, but also because it cleans it up and it makes it easier to graph later on. So I'm going to leave the left-hand side alone for the moment. What does x minus negative 4 mean? Right, it means the same thing as having x plus 4. So if I do x plus 4 instead, then it will be easier when it comes to distribution. So the next thing I want to do is I want to distribute the negative 1/2 through. Well, the negative 1/2 times x is just negative 1/2 x. What is negative 1/2 times 4? It's negative 2. And I want it to say y equals at the end, so the last step then is to add the 2 to the left, thereby adds the 2 to the right as well. So I have y equals on the left, and I have my negative 1/2 x. I'm sort of out of space there. I'll try to do that just a little bit. Negative 1/2 x on the right. Of course, if we've done it correctly on both sides of my screen, they should match. They do. But there are two ways of getting the same thing. I personally don't care which one you use. You can pick, but you need to show some work on it. So whichever one you pick, you should not be able to start from here and give me the answer here. You just can't. So make sure that you're showing some of the work in between so I know what you're thinking, the process you're going through. All right, let's try another one. This one has actually 2 points given to us. Suppose that the points negative 1, 6 and 7, 0 are on a line. Now, if I want to find the line, I would need to find the slope whether or not parts A and B were written this way. I would still have to do the same steps, okay? I broke it apart because I want you to realize that finding part B really means there's a hidden part A in it as well, which is finding slope. So we're going to find slope. The slope form that I had written down before was y equals y2 minus y1 over x2 minus x1. Now, you might be looking at these pairs and asking yourself, so which one's x1, y1, which one's x2, y2? And the real answer is it doesn't matter. It doesn't make any difference. I usually just let it be the first one is x1, y1, and the second one is x2, y2. But if you chose backwards, your answer you get will be the same. Okay, it won't make any difference at all. So let's use these just so we're writing down the same thing. What is y2 according to that assignment of variables? 0. And y1 is 6. So this is 0 minus 6 in my numerator. What is x2? 7 minus, and what is x1? Negative 1. Be careful about your negatives. It's so easy to lose a negative in these problems. It's minus a negative 1. And of course, minus negative 1 is plus. So I have 0 minus 6 in the numerator, which is negative 6. And I have 7 plus 1 in the denominator, which is 8. Now I realize not all of you have necessarily had proportional and statistical reasoning, which is where we talk about reducing fractions, but you've all had junior high math, which is where you talk about reducing fractions. So anytime you end up with something that can be reduced, I expect you will. 6 and 8 can be reduced. How do I know that? Right, they're both even, they're both divisible by 2. So if I were to divide each one of them by 2, what would I get? Negative 3 over 4. So this is my simplified slope. You might be asking, well, can I turn it into a decimal? You can, as long as the decimal terminates. I don't want you to do something where you had a slope of 2/3 and for you to tell me that the slope is now 0.6 repeating. We just don't see lines written that way. Usually we do see them left in fractional form. But on this one, if you changed this one, it would be negative point, hang on, I left my negative off, negative 0.75. So technically you could do it with decimals if you like them that way, because it stops. All right. we're going to work with fractions instead. So now we have a slope, -3/4, and we have 2 points. How many points do I need? How many points do I need if I have the slope already? Just one. So you get to pick whichever one's your favorite. So looking at these 2 points, my contenders up here, which one's your favorite? I can tell you which one's my favorite. I like 7, 0. Why do you like 7, 0, Rachel?
You don't need to write the 0 makes one less step.
You got it. The 0 makes it one less step. I mean, that's just it. She said that well. The 0 makes it one less step. If you pick the other one, will you get the same answer? Yes, you will. So it doesn't really matter, but on this one, I've got a 0, so I'll usually pick that one. Okay, so what I want you to do is I want you to take just, a minute here, and I want you to use whichever method you'd like, and I want you to find the line with the slope of -3/4 through the point 7, 0. Your final answer should be written in the form y = mx + b. Okay, that's what your answer should look like at the end. Okay, it looks like most of you are done. What equation did we get? Let's just compare and see if everybody has the same thing or if there's some differences. What equation did we get? It should start with y equals, right? Y equals, what was it?
-3/4 x
Plus 5 over what?
and a fourth.
5/4 like this.
No, 21 over.
You changed it into a mixed number. Let's leave it as an improper fraction. That's okay. 21 over 4. The problem with writing it, it's not really a problem, but what happens when we write it as 5 1/4 is that a lot of times it will start to look like 51 over 4 because people don't always use horizontal bars to do the division. So we'll leave it as improper fractions just to be sure that we're all on the same page. Does anybody have, this is correct. If you didn't quite get this, let me just set up both parts of how to do it, and then if you still have questions, just let me know later. So we would have had y, if we do sort of the second method that I did, we would have had y minus 0 equals m, which is -3/4 times x minus 7. If you did it with y = mx + b, you would have the y value, which is 0, equals m, which is -3/4 times the x value, which is 7, plus b. So in either one of those cases, you can either solve for b and write your equation to have the 21 over 4 in it, or you can simplify the equation from the first one, and you will end up with 21 over 4. Any questions on that one? Okay, let's take a look at the next one. This question actually gives us an equation in a specific form that we haven't talked about. The form of this equation is called the general form. It has x's and y's on the same side. It has whole number coefficients. I don't know how many fractions involved on the actually on any of it. Any of the numbers involved are all whole numbers. And the x value is positive. So this is called the general form. So it's wanting us to take this equation and put it into slope-intercept form, and then figure out what is the slope, what is the y-intercept, what is the x-intercept, and then draw a graph. So we got a lot to do. We're going to start with the slope-intercept form part of it. 3x plus 2y equals 8. What would I do first to get this into slope-intercept form? We either need to move the 3x or we need to move the y. I'm probably going to move the 3x because we usually have the y written on the left when we finish these problems, and it's already there, so I would probably move the 3x first. When I move it, I would move it so that it's in front of the 8. So my 2y on the left, and I'd write mine down as -3x plus 8 on the right. Because eventually the x needs to be before the other part to be in the right form too. What else do I need to do? I need to divide by 2. And you can write it either like this, everybody look at that real quick, where you write the whole right-hand side divided by 2, and that's fine. Or you can write each piece divided by 2, which kind of makes it a little bit more obvious that there is a little bit of simplification to do. So I like to write mine like that. It tells me then that I have a -3/2 x, and what's 8 divided by 2? 4. So this is one of the 4 things I was asked to do, find the slope-intercept form. Okay, so this is slope, intercept form. Another piece I was asked to do was to find the y-intercept, and the y-intercept is very nice because in this form I can see it. What is the y-intercept value where it crosses the y-axis from that equation? You're trying to say, yeah, it's 4, right? But I mentioned earlier when we talked about y-intercept that please do not write down y-intercept equals 4. The y-intercept is an ordered pair, and ordered pairs always have an x-coordinate and a y-coordinate. The b value tells you that the y-coordinate is 4. But the fact that it's crossing the y-axis there means that x is 0. So your y-intercept is not 4, your y-intercept is 0, 4. Okay? You might look at that and feel like that's a technicality, but the problem is that if you write down that the y equals 4, you actually wrote down the equation of a line, a horizontal line at 4, which isn't what you meant. You meant the point where it crossed. So that's why we want to distinguish between those two notations. X-intercept is not as obvious from any of the parts of this problem. We don't set this up to find an x-intercept. So how do we find it? Well, your x-intercept is when y equals 0, just like your y-intercept is when x equals 0. So you have a choice. You can either take the original part of the equation of the line, or you could take your y-intercept part of the line at the end, either of those forms, and you want to plug in 0 for y. Now, of the two forms, which one do you think it's easier to plug in 0 for y? I think the original one, the top one. There's nothing wrong with the bottom one, but it's already got fractions in it, right? I don't have to deal with fractions, so I don't have to. So let's deal with that top equation and plug in x or y equals 0. So it's 3 times x plus 2 times 0 equals 8. So obviously the 2 times 0 goes away, and all I'm left with on the left is 3x. How then would I find x? I would divide by 3. So the x value that I just found was 8 over 3, but that's not my x-intercept. My x-intercept is, again, an ordered pair. The value of the x-coordinate is 8 over 3. What's the value of the y-coordinate? 0. You got it. So we've done 3 of the 4 parts. The 4th part is to graph this. And I want to show you a couple of different ways that you can graph this, given that we found a lot of information. The first thing I need to do is move my stuff. Isn't that a cool feature that I just used? Yeah, one of my favorites. Okay, so we're going to draw a grid, xy coordinate plane. What's wrong? It's too All right, so let me show you one way to graph this. One way is to use the slope-intercept form that you found. When you did that, you found that the b value, the y-intercept coordinate, was a 4. So literally, you could plug in here the 4 as your y-intercept, right there at 4. And then your slope is negative 3/2. If you think of it in terms of rise over run, the rise is negative, which means it's actually a drop, goes down. So you would count down 3, and then the run always runs to the right, and so you go right 1, and your next point would be here. You have 2 points. All you need is 2 points to draw a line. Okay? So once you have those 2 points, you can connect them, you have your line. Oh, was it 2? Yes, I'm sorry. 3 over 2, you're right. I forgot I had a 2 there. Thank you. 3 over 2. Okay, so there we go. So that's one of the ways to graph this. Now, that's probably the nicest one for this particular graph, but I'd like to show you the other one because maybe, just maybe, you actually didn't have to find the slope. Maybe all it asked you to find was the x-intercept and the y-intercept. And if you only knew how to find your graph through this method that I just did, you'd have to do an extra step, namely finding the slope. So let's say you only knew your x-intercept and your y-intercept. Well, I've plotted my y-intercept. My x-intercept was at at 8/3. Alicia did one earlier where she turned that into a mixed number. That would actually be pretty helpful if I was plotting this. This would be the number 2 and 2/3. Okay, right? 8 divided by 3 would be 2, with a remainder of 2/3 left over. In terms of a graph, here's 1, here's 2, here's 3. So 2 and 2/3, let me use it in yellow because it's kind of hard to see, is about right here. And again, if all I need to graph a line is 2 points, I can use any 2 points. So if I happen to know the x and the y-intercepts, I can use the x and the y-intercepts and graph the line instead. Now, either way you do it, you're going to get the same picture. It's not going to be any different. But there are different ways to think about the graphing. All right, one more. This one's a little bit different. It asks us about things that are perpendicular, which we looked at before. But the point itself is a little bit, or the question itself is a little bit different than that other one. It says to find the equation for the line containing 3, 5, but it has to be perpendicular to the y-axis. Now, it does not tell me on this one that I have to graph it, right? But I contend that graphing it will make it easier to figure out what it's asking me. So that's my suggestion. I already told you that I'm a visual person, so for me, this makes sense to think of visually. I have the point 3, 5. So if x comes first, which it does, it means I count 3 to the right, and then I have 5, so I count up 5. So this is my ordered pair 3, 5. And then it tells me that I need it to be perpendicular to the y-axis. What will that type of a line be? It will be horizontal. So it will look something like this. Draw arrows on the end of your lines. I keep trying to remember to, but yes. Look something like this. Now again, it didn't ask me to graph this line. But for me, once it's graphed, it becomes a much easier question to simply say, now, what is the equation of what I graphed? Any ideas? What would the equation of this yellow line be? It is. Can you explain why, Rachel?
It has a slope of 0.
Mm-hmm.
0 times x is 0. Intercept or y-intercept.
Yeah. So y equals 0 times x, and then the the y-intercept, excuse me, was b is 5. And then 0x is 0, so you get y equal 5. Okay. You could also, at this point, after having recognized that it's a horizontal line, remember that acronym that I told you earlier, if that helps you, HOIVUX. Because I'm dealing with a horizontal line, I'm on the first half of that acronym, which means I have a y equals equation as opposed to an x equals equation. Another way you could think about this one, which is also pretty helpful, is you could recognize that everywhere along this line, even the points that are in between, they all have the same y value, 5. So the equation has to be y equal 5, because everywhere along the line, y is 5.